the timeless past.
The deep past, before Homo sapiens. Our story begins in Africa, but an Africa we wouldn't recognize today. Imagine a landscape shifting between dense forests and open grasslands. This was the world of our earliest known relatives, teeming with massive predators and fierce competition. Around 7 million years ago, a new kind of primate emerged. Known to science as Sahelanthropus chidensis, this creature was a mosaic of old and new. It had features for life in the trees, but tantalizing clues from its skull suggest something revolutionary was happening. The big debate is whether it walked on 2 legs. While some studies of its bones say yes, confirming it as a habitual biped, others argue the evidence isn't quite there yet, leaving its exact way of moving a hot topic of research. This adaptation, bipedalism, wasn't a sudden leap, but a gradual, hesitant step. So why stand up? The classic savanna hypothesis suggests that as forests shrank, walking upright was a huge advantage, letting our ancestors see over tall grasses and free their hands. But today, most scientists think it was more complicated than that. Bipedalism likely emerged for a mix of reasons across different mosaic-like habitats. Free hands could now carry food, tools, and maybe most importantly, their young, allowing them to cover more ground. This was the first great divergence, the moment our path split from our closest living relatives, the chimpanzees. Over millions of years, this new way of walking was refined. Enter the Australopithecines, a diverse group of hominins who roamed Africa for over 2 million years. The most famous is Lucy, a 3.2-million-year-old Australopithecus afarensis skeleton found in Ethiopia. Her remarkably complete skeleton proved she was fully bipedal, yet she still had ape-like long arms and curved fingers, a clear sign of a life spent both on the ground and in the trees. Lucy's world was perilous. These hominins were small, relatively defenseless, and definitely on the menu. But they survived. They lived in groups, relying on social bonds and a growing awareness of their environment. It is here we see the first glimmers of what would become a hallmark of humanity: cooperation. While it's a bit of a myth to point to a specific Australopithecine fossil, later examples in the hominin record, like a healed femur bone, make a powerful point. For an animal in the wild, a broken leg is a death sentence. To find one that healed means someone cared for the injured individual, brought them food, protected them, and gave them time to recover. This wasn't just survival of the fittest. It was the dawn of compassion. But this was just the beginning. The Australopithecines laid the groundwork. They were the pioneers of bipedalism, the survivors of a changing world. The next big step in our evolution, however, wouldn't be about how we walked. It would be about what we could create with those newly freed hands. The stage was set for a new kind of hominin, one with a bigger brain and a revolutionary idea. The dawn of ingenuity, the first tool makers. As the African climate kept fluctuating, new pressures led to new solutions. Around 2.5 million years ago, a new genus appeared: Homo. The first of this line we knew about for decades was Homo habilis, or handyman, and it earned that name for a reason. Found alongside simple but effective stone tools, Homo habilis seemed to represent a profound cognitive leap. But the story of the first toolmaker is getting more complicated. We used to think Homo habilis was the one and only pioneer. Now we know the oldest Oldowan tools date back to around 2.6 or even 2.9 million years ago and have been found near different kinds of hominins, including Paranthropus and other early members of the Homo genus. It's likely that several species were experimenting with this new technology. Imagine the mind that first saw a tool hidden inside a rock. The foresight to understand the right angle to strike it, to flake off pieces and create a sharp edge capable of butchering a kill. This was the dawn of reason. These first tools, the Oldowan industry, were simple choppers and flakes, but they were game changers. They unlocked a new source of calories, meat and bone marrow, previously off limits. This richer diet fueled the growth of the most energy-hungry organ in our body, the brain. This feedback loop, better tools, better food, bigger brains, even better tools, kicked our evolution into high gear. This brings us to a giant of human evolution, Homo erectus. Appearing around 1.9 million years ago, Homo erectus was different. They were taller, with bodies much like our own, and their brains were significantly larger. They created more advanced, beautifully crafted tools called Acheulean hand axes, a technology so successful it dominated for over 1 million years. But the greatest innovation of Homo erectus may not have been made of stone. It might have been the mastery of fire. Can you imagine a world of absolute darkness at night, of gnawing cold, of predators lurking just beyond the moonlight? Now, picture the first controlled flame. While the evidence is debated, with some of the earliest strong claims for controlled fire dating to around 800,000 years ago, many researchers believe Homo erectus was taming flames much earlier, perhaps over 1 million years ago. Fire provided warmth, light, and protection. But its most profound impact was on our diet. Cooking makes nutrients more digestible and kills dangerous parasites. This external stomach freed up even more energy for our expanding brains. The hearth also became the center of the community, a place to share food, communicate, and strengthen social bonds. It's around the fire that culture truly began to glow. It was Homo erectus who first stepped out of Africa, spreading into Asia and Europe. For over 1 million years, they were the dominant hominin on the planet. During this time, the common ancestor of our species and our closest extinct relatives, the Neanderthals and Denisovans, lived somewhere between 750,000 and 550,000 years ago, though the exact timing is still debated by geneticists. These groups would descend from archaic humans like Homo erectus, and their paths would diverge, setting the stage for a new kind of human, one that would not just inhabit the world, but change it forever. A Pan-African Genesis, the birth of our species. For decades, the story of Homo sapiens seemed simple. We were born in a single Garden of Eden in East Africa around 200,000 years ago, and from there, we conquered the world. But in the last few years, groundbreaking discoveries have torched that old script, revealing a far more fascinating origin story. The story isn't about one place, it's about an entire continent. The revolution began far from the traditional heartland of human origins, at a site in Morocco called Jebel Irhoud. In 2017, scientists redated fossils known for decades, with staggering results. The remains belong to early Homo sapiens who lived a mind-blowing 315,000 years ago. This find pushed back our species' origin by over 100,000 years. So, what did these earliest members of our species look like? They were a fascinating mix of modern and archaic. Their faces were surprisingly like ours, small and tucked under the brain case. You might pass one on the street and not look twice. But their brain cases were long and low, more like those of earlier hominins, not the high, rounded skull we have today. This discovery was profound. It meant our modern face evolved early, while our brain's shape, and likely its internal wiring, continued to evolve within our own species. Jebel Irhoud completely changed the map. This wasn't an isolated pocket of evolution. Sophisticated stone tools found there were remarkably similar to tools from the same period all over Africa. This pointed to a radical new idea, a Pan-African origin for Homo sapiens. This model suggests our species didn't pop up in one spot. Instead, our emergence was a continent-wide phenomenon. Imagine Africa 300,000 years ago, a patchwork of different environments. Groups of early Homo sapiens were scattered across this landscape, from Morocco to Ethiopia to South Africa. Often separated by deserts and forests, they developed unique local traits. But when the climate shifted and green corridors opened, these groups would meet, share technology, and, crucially, interbreed. This process of separation and reconnection gradually stitched together the features we now call modern. The modern face might have appeared in the north, while the globular brain case evolved in the south. Over tens of thousands of years, gene flow wove these innovations into the single variable species we are today. Other fossils support this continent-wide story. The Omo eye skull from Ethiopia, long thought to be 195,000 years old, has been redated to at least 230,000 years old. And the 260,000-year-old Florisbad skull from South Africa also fits into this complex mosaic of evolving features. Our species wasn't born in a single cradle but forged in a network of diverse populations across our ancestral homeland. This Pan-African genesis gave us a deep well of genetic and behavioral diversity right from the start. And it was this adaptability, forged across an entire continent, that would be the key to our ultimate success. Out of Africa, the Great Dispersal. For hundreds of thousands of years, Africa was home. But Homo sapiens was a restless species, destined to explore the entire planet. The story of how we did it is a saga of courage, adaptation, and encounters with other kinds of humans. The first forays out of Africa were probably small and tentative. There's evidence of early, and perhaps short-lived, dispersals into Greece around 210,000 years ago and the Middle East around 185,000 years ago. These were whispers of the epic to come. The main successful wave of migration that gave rise to all non-African people today seems to have happened later, probably in a window between 70,000 and 50,000 years ago. Whatever the cause, climate change, population pressure, or pure curiosity, small bands of hunter-gatherers began to move. As they moved into Eurasia, they entered a world that was already populated by our evolutionary cousins, the Neanderthals and Denisovans. For a long time, we thought our ancestors simply replaced them. But ancient DNA has revealed a far more intimate and complex truth. We met them, and we interbred. New genetic studies are clarifying this picture. The main period of interbreeding with Neanderthals likely occurred around 50,000 years ago and lasted for several thousand years. This wasn't a single event, but a prolonged period of contact. As a result, most people of non-African descent today carry between 1% and 2% Neanderthal DNA. This inheritance wasn't just a quirk. It had real consequences. Some of these genes are related to our immune systems, skin, and metabolism, likely helping our ancestors adapt to new environments and diseases outside of Africa. Less is known about the mysterious Denisovans, identified from just a few bones in a Siberian cave. Yet their genetic signature is also in us, especially in populations in East Asia and Oceania. Some people in Melanesia, for example, carry up to 5% Denisovan DNA. This tells us that as our ancestors spread, they met and mixed with yet another distinct human group. These encounters showed just how similar we all were. These weren't different species like lions and tigers. They were different versions of human, and their story is now woven into our own. Following coastlines, one group of pioneers made it to Australia by at least 65,000 years ago, a stunning feat requiring open water crossings. Another group pushed into Europe, a Neanderthal stronghold. The journey was hard. These were Ice Age worlds, far colder than the African homeland. Survival demanded sophisticated tools, tailored clothing, and complex social networks. Our ancestors painted incredible art deep inside caves, created intricate carvings, and buried their dead with ceremony. They were developing a rich, symbolic culture, and this cognitive toolkit, more than any physical advantage, may have been our secret weapon. The last human standing, conquering the globe. The final chapters of our global expansion are some of the most dramatic. As our ancestors established themselves in Eurasia, the Neanderthals and Denisovans dwindled, disappearing from the fossil record around 40,000 years ago. Why did we survive while they vanished? The reasons are still debated, Perhaps it was our more sophisticated technology, larger social networks, or quicker adaptation to climate change. It's possible we simply absorbed them into our larger populations. Whatever the case, by about 30,000 years ago, Homo sapiens was almost the only human species left on Earth, though some other hominins like Homo floresiensis may have survived until around 50,000 years ago. But there was one last frontier, the Americas. For decades, the consensus was that people first arrived around 13,000 years ago, crossing the Beringia land bridge from Siberia. Here, too, the story has been radically rewritten. The evidence comes from a mind-blowing discovery at White Sands National Park in New Mexico, fossilized human footprints. A 2021 study dated these tracks to between 21,000 and 23,000 years ago. This was a bombshell. It meant humans were in the Americas during the peak of the last ice age, when massive ice sheets should have made the land bridge journey nearly impossible. The discovery was initially controversial, but follow-up research using independent dating methods has repeatedly confirmed the original age, making the case for this earlier arrival much stronger. So how did they get there? These early dates have given a huge boost to the Kelp Highway hypothesis. This idea proposes that people migrated down the Pacific coast in small boats, living off the rich marine resources found in coastal kelp forests. This would have allowed them to bypass the massive inland ice sheets. With the settlement of the Americas and eventually the remote islands of the Pacific, our species had done something no other had ever done. We colonized the entire planet. From the frozen tundra to arid deserts, from the highest mountains to the most remote islands, we had made every corner of the globe our home. Our 300,000-year journey from a network of populations in Africa was complete. From a hesitant first step onto 2 feet 7 million years ago, to the mastery of fire and the invention of tools. From a sprawling, continent-wide genesis 300,000 years ago, to a global journey that saw us meet and mix with our ancient cousins. From Ice Age footprints on a New Mexico lake bed to the footprints we now leave on the moon. The story of human origins is our story. It's a story written in our bones, in the stone tools we left behind, and in the very code of our DNA. The stunning new evidence of recent years has shown us that our history is richer, deeper, and more wonderfully complex than we ever dared to imagine. We are not the descendants of a single tribe, but the inheritors of a vast, continent-spanning network of ancestors. We carry within us the genetic echoes of Neanderthals and Denisovans, a testament to a time when we were not alone. Our journey has been one of incredible resilience and unparalleled adaptability. We survived ice ages, supervolcanoes, and countless other challenges. We did it not because we were the strongest or fastest, but because we learned to cooperate, to innovate, and to see the world not just for what it is, but for what it could be. The story of the first humans isn't over. It continues in each of us. We are the legacy of that 300,000-year journey, the last humans standing, carrying the torch of consciousness into an unknown future. What will our chapter in this epic saga be? That's the story we are all writing, together. If this journey into our deep past blew your mind, please give this video a like and subscribe for more exclusive stories from our incredible history. And let us know in the comments, what part of our human story do you find the most fascinating? Thanks for watching.